Let's talk about dispersion. And to begin with, I have a confession. Back when we talked about wave speed, I lied. I said wave speed is determined by the wave type, the medium, and the properties of the medium, but in fact it's also determined by the wave frequency. Now the reason I lied is because most of the time this doesn't matter. This is a small effect, and when you're talking about sound waves, when you're talking about waves through longitudinal waves through a rope, it really doesn't have any significant effect, and so there's no need to mention it. It just adds a level of complexity that isn't needed. But this is a very real effect. It does matter sometimes, and it leads to observable phenomena such as rainbows. So let's talk about it. So this is dispersion. It says, and we're talking about this with regards to EM waves. Different frequencies have different speeds through a non-vacuum medium. Now this is important. Non-vacuum medium, because through a vacuum, all EM waves move at the speed of light. But when they're moving through something else, like water, different frequencies will have different speeds. This is what leads to rainbows, because the different frequencies move through water droplets. They move at different speeds. Consequently, they refract differently, and they get separated, and you end up getting a rainbow. Now remember, this is a very important thing to remember, and that's the index of refraction. N equals C over V. So I was talking about they move at different speeds, and so this affects the index of refraction. The index of refraction is actually a different value for the different frequencies. And that's what's going on in this graph. In this graph, we have the different frequencies down here on the x-axis. This is terahertz. Tera is 10 to the 12th. And here is N. This is the index of refraction. And this is just some made-up dispersion graph. So this doesn't reflect, to my knowledge, any actual material, but just kind of made one up here. And it just shows what the different values for N are for the different frequencies. And let me just say, this is actually exaggerated in this particular graph. In actual materials, N might only vary by 1,000th or a few thousandths as you go among the different frequencies. So it's a very small effect, but it is significant enough that, again, you can observe it, and again, it gives rise to rainbows. So it is an important effect, but it's pretty straightforward. It's just that different frequencies have different speeds through any medium other than a vacuum. In a vacuum, they all have the same speed. Anything else, the speed's going to differ.